to the generative AI series, and part of this series we will be focusing on various topics related to generative AI. Primarily they are going to be focused on AWS and some of the other topics which we will also see, which are going to be more focused around generative AI specific functionality. So in today's topic, we first are going to cover the very basic, and this is going to be about AI. So first thing, if we look at AI, because some of these basic terms are equally important to know, because we also need to have an understanding that how generative AI is linked with the AI and the overall artificial intelligence ecosystem. So if we look at, by definition, AI is basically when computers try to act like humans by learning, thinking, or they try to make the decisions. If we take an example of a chess playing computer where it owns strategies to play and win, where AI is basically about making machines smart enough to solve problems like calculator, but again it is actually much more advanced if we just compare with the calculator. So AI is basically computer system that can perform tasks that usually require human intelligence, like recognizing speech, making decision, or solving some of the complex problems. So we can also think like where we can have two main types of AI, where there can be a narrow AI and general AI. Narrow AI could be where system designs for specific tasks like playing chess or identifying some of the photos, whereas general AI is primarily around systems that could potentially handle any of the intellectual tasks like humans. So primarily the core area of AI is going to be, or if we look at machine learning, is also one of the subcomponent of it, where uh, computers learn from examples and experience rather than following the strict rules. Like if you might have heard about where it basically trains with the help of labels. Like if we think about machine learning, it's basically a type of AI or type of artificial intelligence where computers learn from examples instead of being told exactly what to do. So anything could have like multiple pictures, multiple examples, related data or labeled data, and based on that, what they do is they work. Where, let's suppose if we give it our mailbox, we give it a task like filter spam mails, right? Where we give the characteristics of spam email, how it looks like, what it contains in the body, what subject it begins from, what subject it ends from. So all that characteristics of it, if we give it to machine learning, it will be able to detect similar emails wherever it will find those characteristics. Let's suppose we also give it a task where suggest movies or songs which we may like, and we can define our own characteristics, our likes, dislikes, what we want to watch, all that we can define. Now, even machine learning has got lot many use cases around cybersecurity, where it helps spotting some of the unusual activity, like someone trying to hack into your account. Also, it also became popular when computers got better of finding patterns in huge amount of data, like predicting weathers or recognizing faces in photos, which we might have already seen part of iPhones, where or even though Android phones have got it. So this is how. So when we have certain amount of data, based on that collected data, we want to make a forecast, predictions, recommendations, pattern recognition. All these are characteristics of machine learning. Now let's understand what is deep learning, how they are connected. So deep learning is basically a special kind of machine learning. So from where machine learning uses neural network which try to work like the human brain. So the origin was that it creates something which think like a human brain, where deep learning takes machine learning a step further by using neural network to mimic how the human brain works. And the reason why we call it a deep, because it involves multiple layers of these networks. For example, imagine if teaching a child to recognize handwriting, deep learning can do this by looking at thousands of handwritten examples and learning how to spot letters, even if the writing is messy. So deep learning is going to be used for where we can use it for voice assistants like Alexa or Siri, which we might have already seen, where it understands based on the instructions, based on the question we ask, it answers to us, right? Even though if you look at the example of self-driving cars, where they will be able to see the stop signs on the roads, where they'll also be able to see and recognize pedestrians and other vehicles. Even if you look at from the medical scans, where finding out tumors in X-ray or in MRI, all that will be where with the help of deep learning, it will be able. It is a lot easier to recognize. So here, if we look at now what, and within that we have further categories, right? We have got categories where we have got supervised learning, where we already talked about that, how it learns from the labeled data, like teaching with the correct answers, where you have photos of the dogs, or where they are already labeled. So you might have already seen part of your phone where it categorizes like how many times you've been to outings, and then or how many times you've been clubbing. So all those pictures, what it does is it groups them together. So it finds out similar patterns, and based on that, what it does, it is going to put those pictures part of that. Now, if we see that, whereas unsupervised learning is going to be find patterns in the data without label answers. So here, what it is going to do, based on your customer habit, like if you've been visiting a restaurant quite frequently, where it is going to find out the pattern, like group of people, what they are liking, what they are disliking, and based on that, what it is going to do is it is going to learn from those practices. Now, what we have got is we have got reinforcement learning. So within the reinforcement learning, if we see, so basically the reinforcement learning is like, if we take an example of a puppy. So suppose we are teaching a puppy a new trick, where we don't exactly tell the puppy what to do, but we reward it when it does something right. Over time, the puppy learns to perform the trick to get the treat. Like it knows how to get better based on what it has been instructed by. So that's the basic idea behind reinforcement learning. So where reinforcement learning, where we will have an agent, we can assume like a puppy, that interacts with an environment, where agent goal is to learn how to make decisions that will earn it most rewards over the time. And some of the key components it is going to have is going to be agent, where this is going to be a learner or decision maker. In our example, where it's the puppy. Environment is going to be, this is everything that agent interacts with. For example, our puppy, it's in the room, it's in within the control, within the trained environments. And state, it is going to be the current situation. So where the puppy, it might be where it's standing, what position it is on. And then it also has got action category, which is going to be the things where the agent can do. If you look at our example, where our puppy can sit, stand, roll over, play, jump, sit, sleep, all those things it can do. Now we create a rewarding system around this, so which is going to be the feedback from the environment when the puppy does the right thing and it gets treat, and treat is like, you can think of like it's a reward system. Now, if we further deep dive into it, so here the step one is going to be where agent observes its current state. Based on this state, it chooses an action where action changes the environment, leading to a new state. Whenever we have environment which provides a reward based on the learning, it is going to put that into positive or negative. So here agent uses the experience to improve its decision making for the future. Like we can already see the example of the Tesla, right? It has trained on certain parameters that it is not supposed to hit pedestrian. It is not. It is supposed to be within the controlled speed. It has to look at the road signals, and then it knows good or bad, right? So here, and over the period of training, it is keep on improving, right? So now if we take another example of robotics, where imagine teaching a robot to walk. We can't program every single moment, right? Same goes with the self-driving cars. So we use reinforcement learning so that robot can try different leg movements, and we reward it for staying upright and moving forward. And over the period of time, it learns the most effective way to walk, right? Uh, why it is important and why it is gaining a lot of attention? Uh, because what it has got is like, if you see, reinforcement learning is basically, it can solve some of the problems we don't even know how to solve directly, right? Instead of programming a specific solution, like machine learning, we create a system that can learn to find solution on their own. And that's exactly what is happening if you take example of self-driving cars. They effectively use reinforcement learning to navigate road safety, so that the car's control system is the agent, the road and traffic area, the environment, actions, which also include steering, accelerating, and braking. What is the reward then? Safe and efficient travel. That's what the reward would be. So that's how the reinforcement learning would work. Uh, Now, if we look at a generative AI, so generative AI is basically, if we look at, it's the latest and most exciting part of AI. We already have a lot of buzz in the market. 2024 has been more around experimentation, try and error. Lot many new releases have happened, and there is already a lot of buzz, right, in the market, where the primary purpose of generative AI, I'll take a simplest example of pen, right? Pen or marker, where it can be a product. What we can do, where we can use machine learning, we can use machine learning to find out some of the forecasts which can be used for the marketing of that marker product, the marker which I'm taking as example as a product, where it can look at your inventory, do the forecasting report, and make some of the recommendation for the customers who are buying that marker, that, you know, with the marker you can buy duster, like that, all these things. We already have talked about machine learning. Whereas generative AI, what it can do is it can create interesting stories to sell the product in the market, right? It can create some high definition images, high definition and interesting videos based on based on what instructions it has been given. And that's the reason it has got a lot of potentials. Like you already see, like ChatGPT, which, or Anthropic has got various models. So we already have lot many products available in the market. We have products available for image creators where applications generate artwork or design ideas based on the input. It is already have started helping the developers to write super quality code without making a lot of error, provided it has been given clear and crisp and to the point instructions, right? It has a capability. uh, Now if we look at how it works, it basically has got a large set of data, and based on that it basically has a capability to predict the next word in a sentence, like an autocomplete on your phone or mail functionality, which you might have already seen. It also has a capability to write a whole story or summarize new article, right? Now, if we look at what additional things, it also has got contextual understanding. If you provide the clear and crisp context to it, it has as what it can do is it can take a help of vast amount of data, and then it builds a complex and hierarchical understanding of the word, where we give the set of words like weather is great, or AI is already solving many problems. Like that, it is going to make keep a pattern, or will do a hierarchical pattern, and it will also have the understanding of that. And this is similar to how humans develop knowledge. We don't just memorize the facts, but we understand how different places and information relate to each other. For artificial intelligence, this means creating a structured representations of data, whether it is a text, images, or other types of content. And like if you see as a human, we also behave differently in different environment, right? Where we behave differently at work, we behave differently in the playground, we behave different in the gathering. So like that, it also has got more of the contextual understanding, and based on that, it is going to answer. And at the same time, it has got lots of data. So here, the AI ability to focus on the most relevant part of the input, what you provide, just as a human can pick out important information. AI is going to use sophisticated algorithms to determine which part of the input are going to be most crucial for generating an appropriate response. Now let's talk more about, like, if we see the different examples, where we can take an example where generative AI identifies keywords, where if we give a sentence like AI will the word, what it is going to do is it is going to access the vast database, and then it is going to look at various words, set of words, and based on its learning, it might, based on the input you give, it will predict create as the next word, where it says the AI will change the word, right? It is going to use the change as part of the context for the next prediction. And this process is going to be in iterations, where it continuously keep learning it and keep providing as an output. So this is going to be the best thing about AI and its ability to create innovation solutions to complex problems. And that's the reason what you see is that it is gaining a lot of attention and disrupting various domains already. So now if you see, there is a DALL-E, there is a ChatGPT, there is Anthropic, there is Meta Llama, lot many products are already available in the market, right? Now what makes a generative AI fascinating, right? So it's element of controlled randomness, right, where it does not give you a random answer. Instead of always choosing the most statically likely next word, the AI incorporates a degree of unpredictability, where this achieved through a technique like a temperature sampling or nucleus sampling. For instance, while we create might be the most probable next word in the first example, if we go back to the example which we talked about, the first example, AI might sometime choose alternative likes learn, analyze, or adapt. So this randomness is key to the AI's ability to generate diverse, creative, and engaging responses based on the input you provide. Sophistication of these models is also a result of training on enormous datasets, where encompassing much of the publicly available information on the internet is also going to be gathered, will be looked at. And this is extensive training allows AI to develop a broad and deep understanding of language and facts and concepts across numerous domains. So the models can recognize patterns, understand the context, and generate human-like text across a wide range of topics and styles. If we look at the real-world use cases, what you would see is that there is already a huge adoption of code-generated products like Amazon Q, which already has a capability to write a lot more better quality code, a lot faster at, a lot secure and secure, of course, if you compare to the human written code. So, and at the same time, there are a lot many other use cases which are also like agentic AI is also has also been one of the recent one where what you can there's now focus on more on the reinforcement learning, which we will talk in the for the chapter. Now, what is agentic AI? Agentic AI is something which is one of the new aspect, right, where it is gaining a lot of attention. So, agentic AI is basically is going to be, you can provide various conditions where you can have you can give different direction to it. There can be a, so basically it is a system that can act automatically, and it has got a capability to make the decision, carry out tasks with the minimal human intervention. So if we see traditional AI models that simply respond to the prompts, agentic AI can take initiative and work towards goal, where it can have an autonomy, where it can operate independently. It can be a goal-oriented, where it works towards specific objective. It can have adaptability, where it adjusts its approach based on the situation. It has a capability to do the decision making, where it can make choices without human input, and to make that decision, if it requires to look at various data from the different data sources, and for that it has to do certain code execution, run certain function, it can do that, right? It can also do the task decompositions, where it can break down complex tasks into smaller, manageable steps. So like that, it is a lot more capable. So if we do a quick comparison between traditional AI, like a standard chatbot, where it waits for input, responds based on the predefined patterns, doesn't maintain long-term goals, and it is also limited to the scope of its initial programming. Whereas agentic AI can initiate actions, and it can also plan and execute multi-step processes. And it also maintains and works towards long-term objective. And in some of the follow-ups session, we'll also see that how do we decide, or how single agent and multi-agent works, right? So if we look at some of the real-world examples, like if you are planning for a vacations, then traditional AI may be able to just give you a flight to Paris if that's the input you have given, or provide a list of flights is another, it is going to give you that output. Whereas agentic AI can do, where you can tell agentic AI, plan my vacation to Paris, where it is going to do the following. It is going to ask for your available dates, find out suitable flights, book accommodation, plan an itinerary, make restaurant reservation. So it can do multiple steps for you. Like it is going to, where it is going to take the initiative, break down the task, and work through it step by step. If we look at some of the components of agentic AI, there is a planning module which creates strategies for achieving goals. There is a knowledge base which store the information and learn from the experiences. And then we have got decision making engine which basically choose the best course of action, and then based on that it takes there is an action execution module to carry out choose an action. So where if you say that as a user, I want to go ahead and book the ticket, it will have a capability to take that action. It will also have a perception module to understand and interpret the environment, and at the same time it has got the learning module to keep on improving the performance over the period of time. So there are some of the applications which are already, there are some of the organizations who have already started using them to automate lot many internal tasks. Basically, it has got capability to work as a personal assistant that can manage your schedule, make reservation, handle correspondence. It will have a business processes automation that can also oversee entire workflow. Scientific research you can do, autonomous vehicles, they can navigate complex traffic situations. So lot many use cases are being looked at, and within generative AI, this is going to be one of the game changer capability which is going to disrupt the market massively. If we look at some of the challenges at the moment, so ethical decision making, ensuring AI makes morally sound choices, again, making it secure, where preventing unintended consequences of autonomous actions, transparency, understanding how and why the AI makes decisions, improving the accuracy is also one of the biggest concern at the moment. So these are some of the things which are being at the moment. So now if we look at the future of the agentic AI, where AI develops, we can actually expect to see more sophisticated AI assistant that can handle complex and multi-step tasks across various domains. And this is something which is going to change the industry, disrupt the industries, streamlining the different processes and open up new possibilities for human and AI collaboration, where you can have human in a loop to ensure that everything is in place, what was expected. This is all we have for today's session, and stay tuned for further more session with the similar topics. Thank you.